We're going to start in this chapter of systems of equations and matrices using Gaussian elimination to solve a system. And so we've got three equations here in three variables: x plus 2y minus 3z equals negative 28, 3x minus y plus 2z equals 3, and then the final equation is negative x plus y minus z equals negative 5. And we're going to start by reordering these. And this becomes important once we start getting into augmented matrix and row echelon form and such as this. But we've had some experience solving systems of three equations and three variables before, and we may or may not have reordered these, but we're going to do so here. So I'm going to keep the first equation in place: x plus 2y minus 3z equals negative 28. And then I'm going to move equation number 3 into the second position. So now I've got negative x plus y minus z equals negative 5. And then lastly, the third equation, 3x minus y plus 2z equals 3. Now, we're wanting to eliminate one of the variables from each of these equations, and we're going to start here with eliminating the x. And then that'll give us two equations and two variables, and then we'll proceed from there to eliminate a second variable and just solving for a third variable, and then we substitute our way back up, if you will. So I'm going to take these first two that I reordered, and I'm going to start there. So I've got x plus 2y minus 3z equals negative 28. And we're going to add negative x plus y minus z equals negative 5. And you can see why I reordered these, because I can eliminate the x value. And so it's x minus x, that's going to cancel out, and then we're left with 3y minus 4z equals negative 33. And now I'm going to take the first equation and the third equation and work to eliminate the x value from those two. Now, so if I'm looking at this equation and this equation, if I multiply that first equation by negative 3, the entire equation by negative 3, then I can add it to that third equation and therefore eliminate the x value. So let's start with that. So I've got negative 3 times x plus 2y minus 3z equals negative 28. And let's see, that's going to yield negative 3x minus 6y plus 9z equals, and let's see, I may need a calculator, negative 3 times negative 28 equals 84. And we're going to add those two together. Oh, excuse me, not yet, not add yet. Then we're going to add it to 3x, the third equation, minus y plus 2z equals 3. And let's add that. So the 3x and the negative 3x are going to cancel. And then we've got negative 7y. Let's go scrunch it down here at the bottom. 7y plus 11z equals 87. Now we're going to then take these two equations and we're going to eliminate the y variable, but we're going to do that on the next slide. Well, here I've got the two equations that we came up with after we eliminated the x value. And now we want to work to eliminate the y value and solve for z. So I got 3y minus 4z equals negative 33. And I've got negative 7y plus 11z equals 87. Well, if I multiply the first equation by 7 and the second equation by 3, I'm going to be able to eliminate the variable y. So let's get about doing that. So I've got 7 times 3y minus 4z equals negative 33. All right, well, 7 times 3y is going to be 21y. And 7 times negative 4z is going to be negative 28z. And 7 times negative 33, 7 times negative 33 is equal to negative 231. All right, then let's work on this second equation where we're going to multiply it by 3. So I got 3 times negative 7y plus 11z equals 87. And so 3 times negative 7y is negative 21y. 3 times 11z is then going to be plus 33z. And 3 times 87, 3 times 87 is 261. And now we can add these two equations together, this equation and this equation, and we will eliminate the y. So let's go about doing that, and we'll be able to solve for z. So let's see, 21y minus 28z equals negative 231, and we're going to add to that negative 21y plus 33z equals 261. And these are going to cancel. We're going to add these together. So negative 28z plus 33z is going to give us 5z equals negative 231 plus 261 is going to give 30, yield to 30. Divide both sides by 5, and z is equal to 6. Now we're going to take one of our two equations here, where we got it into two variables. We're going to work our way back up, and we're going to substitute 6 for z, and I think I'm going to use this one right here. So let's say we got 21y minus 28 times 6 equals negative 231. And then 21y minus, let's see, got negative 28 times 6 is 168. Check my work here, see how I'm looking. Well, I'll tell you what, rather than do it like that, rather than go to that equation, let me do something that's simpler math. Let's substitute z into this equation here. So we got 3y minus 4 times 6 equals negative 33. So we got then 3y minus 24 equals negative 33. We're going to add 24 to both sides, which then is going to result in 3y equals, what, negative 9? Negative 9. And so y is equal to, after dividing by 3, negative 3. So we got two variables here. We got x equals 6 and y equals -3. And then let's go back to what was one of our first equations, which was, let me find it here. Okay, x plus 2y minus 3z equals -28. And let's solve for x. So let's substitute in then x plus 2 times -3 minus 3 times, substitute in 6 for z, equals -28. All right, so x, 2 times -3 is -6. And -3 times 6 is -18 equals -28. And so now x, -6, -18 is -24 equals -28. Add 24 to both sides, and x is going to equal -4. And so our solution is -4, -3, 6. -4, -3, 6. All right, we have solved a system of 3 equations in 3 variables using Gaussian elimination, narrowing down to solving for 1 variable, then going back to where we had just 2 variables and substituting, in this case, in for z to solve for y, and then taking those 2 solutions and go back to one of the 3 original equations. We're using the first to solve for x, and we come up with our ordered triple. Shazam!